This episode of Overview Biostatistics, I will take you to a fundamental concept of statistics that dealing with a natural phenomena in things. Recall that the role of statistics in research, we aim to get the knowledge from the data. So rather than just quantify what was found in the sample, we use statistics to use the variability here or the natural phenomenon here to inference to a larger populations. So the aim of statistics remain quantify error for judgment. Quantify by two components. One is parameter estimations and another is hypothesis testing. The magnitude of effect that we quantify here range could range from what to what. That's the confidence interval here, or parameter estimations, or the p-value that we will talk in detail later. So the natural phenomenon of things is everything is impermanent. It's varied. There is an uncertainty. So if we understand about this nature, its variability, we then easily understand statistical inference. So take an example of some data about 5 records, like 5 people asking for number of cigarettes smoked per day, 2 for subject number 1, 2 for subject number 2, subject number 3 reported no smoking, number 4 2, and the last one 14. So only one data, I call it data set A, is about cigarette smoke per day, and 5 observations. We need to summarize in some number. So if we take the summations of these 5, it is 20, divided by 5, it will be 4. This is the mean. Okay. So the summation is to take the total. The mean is the average, that is about 4 cigarettes per day out of 5 subjects. Now, if we don't use this one, we just rank this data from 0, smallest, to the largest, 14, and take the middle. This is the median. So when we want to say something about the summary of this data set, if we use the mean, we will say, okay, on average, the people smoke about 4 cigarettes per day. But as you can see, 4 is double as large as subject number 1, 2, and 4. For number 3, it cannot be represented at all. And again, the last one, 14. So 4 is not a good representation of any data point here. In contrast, for median 2, so it can represent about 3 out of 5, for example. So there is a variation of the data set that make even the summary of the data differ, that we need to understand about roles of variability could affect about what is the appropriate summary or the conclusion of this data set. Then the variability play a lot roles here. We need then to touch it by this way. We need to quantify it, how large is the variability. So here is how we quantify the variability. We call variance, which is about standard deviations squared. If you happen to confuse or not clear with my jargon a lot in the previous slide, please don't worry for this moment. We will get used to it later. So how can we touch it? You see that? We have 4 as the average. So each subject differ from their average about how much. So we take x, this means this one, minus x bar, this one, for every subject. You see, so we see how far the data that's away from their mean. So every data points we have this departure from the mean, but when we take the summations, it becomes 0. So there is no further that we can do with this. The way to quantify the variability and maintaining the mathematical properties is just like we take a square of that departure, just like an area of something. So get rid of mathematical problem. Then we have the summations of 120, 128. Okay, this is the total summations of the variability of each data point square, differ from their mean square. And then we take the mean of this. So it will be the mean square for each data point, the departure from their mean. So it is called the variance. So if we take a square root of it, it is called a standard deviation, so that we can understand or easily interpret it. Say that on average, the subject smoke about 4 cigarettes per day, but it can be varied by plus or minus 5.67, for example. So this is how we quantify the variability. Okay, so this is called the measure of central tendency, and say inward in summary or on average. The first one is the mean, the second one is the median. So in the situation where the data is highly skewed, we will look at the variability in a graphical presentation, so that we can know its symmetry or skew. This one is skew. We will touch it later. So in the situation where the data is distributed skew, median is more suitable to be used as a measure of central tendency, as I have described earlier. And this one is a measure of variation or quantifications of the variability. of the data. In our elementary school, you might remember about this is the formula. We usually were trained to remember the formula and substitute the number to get the answer without understanding truly about what. In fact, it is this one that you can touch, so you can come back it later. Try to understand about the magnitude or the quantity of the variation of the data. And here is some things that will link to the future concept. We call this degree of freedom by n-1. So in this case, that means we try to draw a sample to get an answer, but we have a freedom to choose any one except the last one. The last one we have no choice to choose, so we lack of freedom. So this is degree of freedom by n-1. Now take a look at an example of data distribution. We have here 3 data sets, A, B, and C. Each data set have 5 observations. Okay, so the first one I just draw from the last slide, this one. I maintain all 3 examples to have the same mean 4. Okay, the same mean, right? But you might notice the difference here. Standard deviations for dataset A is almost twice, a double of dataset B. We've got 3 here. So that means this is heterogeneous. That means the data varied widely. And also skew. Skew means this is in some group, but this is far away from this group. We will see it later. But for this, it's also, 4 plus or minus 3. An example of more or less heterogeneous data, but symmetry. 0 and 8 in each end, and 3, 4, 5 in the middle. That's symmetry. This is skew. And the last data set, every data point close to each other. So the standard deviation is about 0.7. So this is a very homogeneous data. So you might now understand about what is heterogeneous data, what is homogeneous data. It will determine in the sample size calculations, where if we dealing with the data that in nature it is varied widely, we really need a large sample size to be able to conclude things, as compared to a very small sample size. We get the answer. Sample size no need to be large in homogeneous data, for example. And that is why in sample size calculation we really need information about variation or standard deviation. Okay, so I talk about skew and symmetry. So the graphical presentations to illustrate that distribution is called the histogram. The histogram is nothing but just a graphical where we draw the box here. One box represents the frequency of observations, like 0 for this data set is only 1. 2, there is no in 1 cigarette per day. We have about 3 for number 2, for 2 cigarettes per day, 3 people. Okay, and nobody here, and the last subject is 14. So this is highly skewed compared to data set C in the previous slide. It's symmetry here, and the base of the graph or the histogram is narrow. This is wide. So the histogram tell us about the skewness and also symmetry, as well as the how it's varied widely or narrower here than this one. Okay, so I will conclude the slide, this episode like this. The fact of variations is the natural phenomenon of things, that because of things are varied. So when we repeat the study or repeat that sample or do the study again, the same study as we have done in a research, we will not obtain the same statistics that describe the sample we obtain for sure. Whatever it is, either mean of the weight, mean of the cigarette per day, or the prevalence of whatever, it will not be the same. It will be different because of there is a variation. Therefore, statistics or the summary that we obtain from the sample, it will be varied from study to study. Even study the same subject, measure the same thing, it will be varied. For example, the prevalence of a disease in this area, if we do the first time, we will sampling some group of sample, we get 1 prevalence. If we repeat again in the same area, we will draw the sample, we will get the different subject, because the role of chance, the prevalence will be differ from the previous one. If we repeat again and again, statistics or the prevalence obtained from each study will have different magnitude. The prevalence will differ. Therefore, it is hard to believe that the study is the parameter. The statistics is the parameter. What does it mean here? It means that if we conclude that study saying that the prevalence is high, the prevalence is low, that prevalence is lower than what was expected, something like that, in the conclusion, that means we interpret the statistics which obtained from the sample as if it is the parameter that would be obtained in the larger population. So it's hard to believe so. Therefore, we need statistical inference to estimate the parameter from statistics to be used as the basis for the conclusions, not the statistics. Okay, because it's very according to if we repeat again, so we cannot rely on that. Okay, so the data varied widely. This is heterogeneous. If the data vary minimally, we call homogeneous data. heterogeneous or homogeneous determine the sample size. If we're dealing with heterogeneous data, we need to have a large sample size to be able to get an estimate or parameter estimate that is conclusive, or that means narrow, to be able to conclude things. If it is wide, it tends to be inconclusive and we cannot get the answer. See you the next episode to get a closer look at what we do about repeated samples so that we can use statistics to obtain the parameter. See you in the next episode.